SR-750-760 feeder management relays are microprocessor-based relays designed for the protection and management of distribution feeders. They are equipped with 8 output relays for trips, alarms, and start blocks. 14 digital inputs may be configured for different functions, such as remote opening and closing of the breaker, reset, or alarm with a programmable name. The overcurrent protection includes multiple timed and instantaneous elements that incorporate directional control. In addition to the 13 standard ANSI, IEC, and IAC inverse curves, the SR750 and 760 offer 2 flex curves that can be specifically designed for custom overcurrent protection. Feeder protection, fault diagnostics, power metering, and RTU functions are integrated into one economical draw-out package. Relay installation. The relay case can be installed in the panel of a standard 19-inch rack, either alone or adjacent to another SR series unit. Make sure that the front door of the relay is able to swing open without interfering with adjacent equipment. Normally, the relay is shipped in its case from the factory. The relay should be removed from its case before mounting the case in the supporting panel. To remove the unit from the case, first turn off control power before drawing out or reinserting the unit to avoid maloperation. To remove the unit from the case, open the cover by grasping the center of the right side. Press upward on the latch, and then pull the front door, which will rotate about the hinges on the left. Release the locking latch located below the locking handle by pressing upward on the latch with the tip of a screwdriver. While holding the latch raised, grasp the locking handle in the center and pull firmly, rotating the handle up from the bottom of the unit until movement ceases. Rotate the handle to the stop position. Once the handle is released from the locking mechanism, the unit can freely slide out of the case when pulled by the handle. It may sometimes be necessary to adjust the handle position slightly to free the unit. Mounting instructions. Review the dimensions and location of the relay wiring before selecting a location within the panel that is appropriate for the relay. Cut the hole in the panel to the dimensions shown in the drawings. After the mounting hole in the panel has been prepared, slide the relay case into the panel from the front. Apply firm pressure on the front to ensure the front bezel fits snugly against the front of the panel. Bend out the pair of retaining tabs to a horizontal position from each side of the case. The case is now securely mounted and ready for panel wiring. If additional support is desired, the optional SR mounting kit may be ordered. Inserting the unit into the case. If an attempt is made to install a unit into a non-matching case, the mechanical key will prevent full insertion of the unit. Do not apply strong force in the following step, or damage may result. Raise the locking handle to the highest position. Hold the unit in front of the case and align the rolling guide pins near the hinges of the locking handle with the guide slots on either side of the case. Slide the unit into the case until the guide pins on the unit have engaged the guide slots on either side of the case. Grasp the locking handle in the center and press down firmly, rotating the handle from the raised position towards the bottom of the unit. When the unit is fully inserted, the latch will be heard to click, locking the handle in the final position. Status indicators for the 750 system and output relay status, in addition to a 40-character message display and keypad, allow control, programming, and status monitoring without the need for a computer. However, the conveniently located front RS-232 port allows easy connection to a computer for programming and monitoring. The relay's draw-out handle has provision for a wire lead seal to detect unauthorized removal. The relay is packaged in the standard Multilin SR series configuration of a draw-out unit and companion fixed case. The case provides both mechanical protection and is the termination for all connections to external equipment. Current transformer connections within the case are fitted with automatic CT shorting mechanisms. The unit is held in the case by pins on the locking handle, which cannot be fully lowered to the locked position until all electrical connections are fully mated. Any SR750 can be installed in any SR750 case, provided that they have been purchased with the same ground CT option. An index pin keying mechanism prevents incorrect pairing. Relay display. All messages are displayed on a 40-character liquid crystal display to make them visible under poor lighting conditions. While the keypad and display are not being used, the display will default to user-defined status messages. Any trip, alarm, or start block will automatically override the default messages and appear on the display. Pressing the Help key for 2 seconds will initiate a lamp test. There are 2 different displays available for the SR750 relay. These are the Enhanced and Basic. New production units will be enhanced, while older relays already installed may have the Basic display. The main difference between the Basic and Enhanced display is a larger LCD display and the keypad interface. The Basic display uses separate set point and actual keys to enter the main headings. The actual key is used to navigate through the headers of pages of measured parameters, while the set point key is used to navigate through the headers of pages of programmable parameters. The actual key will enter a different actual value heading each time it is pressed. Once you have entered the actual value heading you want to view, the message up and down keys may be used to navigate through the subgroups. The functionality of the remaining keys remains the same as the enhanced display. There are 3 groups of LED indicators on the faceplate that indicate the status of the relay, system, and output relays. The meaning of these indicators is as follows. First, let's look at the status LED indicators. The Relay in Service LED indicates that control power is applied and all monitored input, output, and internal systems are OK, and the relay has been programmed and is in protection mode, not simulation mode. The Trip LED indicates that a protection element that is programmed as a trip function has operated. The Alarm LED indicates that a protection element that is programmed as an alarm function has operated. The Pickup LED indicates that a timed element, such as the timed overcurrent, has picked up and is timing out towards a trip. The Setpoint Group 1 through Setpoint Group 4 LEDs will indicate which of the 4 sets of protection elements is being used to protect the system. If an LED is solid, this means that the indicated group is protecting. A setpoint group LED will flash when that setpoint group is being edited, but only if another setpoint group is being used to protect the system. For example, if setpoint group 1 is the active or protecting setpoint group, but the setpoints under setpoints group 4 are being edited, the setpoint group 1 LED will be solid, and the setpoint group 4 LED will be flashing. System Status LED Indicators. The Breaker Open LED indicates that the breaker is in the open position based on auxiliary contact feedback. The Breaker Closed LED indicates that the breaker is in the closed position based on auxiliary contact feedback. The Reclosure Enabled LED indicates that auto reclosure has been programmed and there are no conditions that would block reclosure. The Reclosure Disabled LED indicates that auto reclosure has been programmed, but there are conditions present that would block reclosure. The Reclosure in Progress LED will illuminate when a trip has occurred and reclosure has been initiated. The Reclosure Lockout LED will illuminate when the programmed reclose sequence has progressed to its lockout condition. The Local LED indicates when the local mode has been assigned to an asserted contact input, allowing the breaker to be opened and closed using the front keypad. The Message LED will indicate when there is a trip or alarm message present in the relay. If there is more than one message, using the Next button will scroll through the messages. Output Status LED Indicators. The R1 Trip LED indicates that the R1 Trip relay has operated or energized. The R2 Close LED indicates that the R2 Close relay has operated or energized. The R3 through to the R7 auxiliary LEDs will indicate that the respective auxiliary relay has operated or energized. The R8 Self-Test Warning LED indicates that the R7 self-test relay has operated or energized due to the detection of an internal relay error. The relay's messages are organized into pages under the main headings of Set Points, Actual Values, and Active Targets. The menu key is used to navigate through the main headings. Each page is broken down further into logical subgroups of messages. The message keys may be used to navigate through the subgroups. For example, when the menu key has been used to select the Actual Value main page, pressing the Message Right key will move you into the A1 Status menu. The message up and message down buttons can then be used to view the headers for the other actual value submenus, such as A2 metering and A3 maintenance. To view the specific information in a subheading, use the message right key. For example, when in the A1 status subheading, press message right to see the heading for virtual input status. The message up and down keys can again be used to navigate the headings under the A1 status subheading. The Enter key has a dual purpose. It is used to either enter the subgroups or store altered setpoint values. The Escape key is also dual purpose. It may be used to exit the subgroups, or it can be pressed to return an altered setpoint to its original value before it has been stored. The Value Up and Down key is used to scroll through variables in the setpoint programming mode. It will increment and decrement numerical setpoint values. Alternatively, these values may be entered with the numeric keypad. The Help key may be pressed at any time for context-sensitive help messages. The Relay Front RS-232 port. This port is intended for connection to a portable PC. Setpoint files may be created at any location and downloaded through this port using the EnerVista setup program. Local interrogation of setpoints and actual values is also possible. New firmware may be downloaded to the relay flash memory through this port. Upgrading of the relay firmware does not require a hardware EPROM change. There are a total of 14 digital inputs that are designed for dry or wet contact connection to other devices. One of the digital inputs, the setpoint access input, has its own common, while the rest of the inputs share commons. The setpoint access switch allows the front keypad to be used to program the relay. This can be wired as a dry contact connection only. When wiring the digital inputs to the relay, it is important that terminal C12 is used as the common for all dry contact connections. This terminal is connected to an internal 32-volt supply, which is used to power the digital input circuitry. Connecting an external source of power or using a wet contact connection with this terminal will damage the relay. When using a wet contact connection, use terminal D12 as the common. The negative side of the external supply must be connected to this terminal. Improper orientation of the wiring can result in damage to the relay. The control power supplied to the relay must match the installed switching power supply. If the applied voltage does not match, damage to the unit may occur. The order code on the terminal label on the side of the drawout unit specifies the nominal control voltage as one of the following. For low voltage connection, the label will read Low 20 to 60 VDC, 20 to 48 VAC. For high voltage connection, the label will read High 90 to 300 VDC, 70 to 265 VAC. Extensive filtering and transient protection are built into the relay to ensure proper operation in harsh industrial environments. Transient energy must be conducted back to the source through the filter ground terminal. A separate safety ground terminal is provided for high-pot testing. All grounds must be hooked up for normal operation regardless of control power supply type. There are 3 channels for phase current inputs, each with an isolating transformer. There are no internal ground connections on the current inputs. Each phase CT circuit is shorted by automatic mechanisms on the relay case if the unit is withdrawn. The phase CTs should be chosen such that the full load current falls between 50 and 100% of the rated phase CT primary. Ideally, the phase CT primary rating should be chosen such that the full load amps is 100% of the phase CT primary or slightly less, but never more. This will ensure maximum accuracy for the current measurements. The maximum phase CT primary current is 50,000 amps. The relay will measure correctly up to 20 times the phase current nominal rating. Since the conversion range is large, 1 amp or 5 amp CT secondaries must be specified at the time of order, such that the appropriate interposing CT may be installed in the unit. CTs chosen must be capable of driving the relay phase CT burden under maximum fault currents. Ground current input connection options. There are 2 independent ground CT connections on this relay. Terminals G10 and H10 are the ground connection. Terminals G3 and H3 can be ordered as a polarizing ground input or as a sensitive ground input. The G10-H10 ground connection is intended for low or zero impedance ground systems. The secondary CT value must be specified as 1 amp or 5 amp when the relay is ordered. The G3H3 ground connection can be ordered as a polarizing ground connection or sensitive ground connection. The relay order code will indicate which ground connection is installed in the relay. An S5 indicates a sensitive ground, while a D5 in the order code indicates a polar ground connection. The sensitive ground is intended for high impedance grounded systems or ungrounded systems. The maximum fault current must not exceed 500 amps. The polar ground is used to set the reference for ground and neutral directional overcurrent. If the relay does not have this option, a phase voltage reference will be used for the directional elements. There are three methods for connecting the ground inputs of the relay to the system. The first is a dedicated ground CT installed on the neutral of the system. This connection is generally used at the system source for polarized ground connections. The second is a residual ground connection. This reduces the cost of implementing ground protection, but it increases the error in the system due to the accuracy limitations of the three-phase CTs. Pickup levels will need to be set higher with this CT configuration. The third method is to use a zero-sequence CT. This provides the most accurate ground protection and allows more sensitive pickup levels for ground overcurrent protection. A CT must be chosen that allows all three conductors to pass through the window. The exact placement of a zero-sequence CT so that only ground fault current will be detected is shown here. If the core balance CT is placed over shielded cable, capacitive coupling of phase current into the cable shield may be detected as ground current unless the shield wire is also passed through the CT window. Twisted pair cabling on the zero-sequence CT is recommended. There are a total of 4 VT inputs available with this relay. They are the 3 bus VTs along with the line VT. The bus VTs are used for measuring the voltage in the system. Power calculations, voltage protection, and frequency protection are all based on these metered values. The bus voltages are also used for the polarization of the directional overcurrent elements. There are 2 different wiring configurations for the bus VTs. A Y connection requires 3 VTs, 1 for each phase. This connection will provide line-to-neutral voltage measurements. An open delta configuration only requires 2 VTs and will provide phase-to-phase voltage metering. Line-to-neutral voltage cannot be measured and will not be displayed. The 750 voltage terminals are internally connected in a Y configuration. If an open delta configuration is chosen for the system VTs, the VB and VCOM terminals of the relay must be connected external to the relay. Regardless of the wiring configuration for the bus VTs, there is a maximum VT ratio of 5,000 to 1 allowed, and the nominal secondary voltage must fall between 50 and 240 volts to allow proper metering and to protect the relay from damage due to high voltages. In order to calculate the nominal secondary voltage for open delta connected VTs, the system line-to-line voltage is divided by the ratio of the VTs installed. Consider a 13.8 kilovolt system with 14,400 to 120 volt VTs. The nominal line-to-line secondary voltage will be 13.8 kilovolts divided by 120, or 120 volts. With a Y configuration, you must take the line-to-line nominal voltage calculated for a delta configuration and divide it by √3 in order to get the line-to-neutral voltages that the relay will be seeing. Considering the previous example, the 120-volt line-to-line secondary voltage will be divided by √3 for a line-to-neutral secondary voltage of 66.4 volts. The line voltage input is used for the synchro-check function of the relay. The relay will compare the voltage amplitude and phase angle, as well as the frequency of the line VT to those metered on the bus VTs. Based on the settings programmed, it will then allow or block the closing of the breaker. The line VT can be connected as either a Y or delta. The relay must be programmed with the connection that is used to allow for compensation of the phase angle. As with the bus VTs, there is a maximum allowable VT ratio of 5,000 to 1, and the nominal secondary voltage must fall between 50 and 240 volts. At this time, it is appropriate to review the terms failsafe and non-failsafe. GE Multilin defines a failsafe relay as a relay that is normally energized and de-energized when called upon to operate. It will also de-energize when the relay control power is lost. Within the relay, there is only one relay that will always operate as failsafe. This is the R8 self-test relay. It has a Form C contact output configuration and will de-energize if there is a problem with the relay. The other 7 relays are defaulted to non-failsafe. They will normally be de-energized and will energize when called upon to operate. If failsafe operation is required from one of the auxiliary relays, their non-operated state can be programmed to energized. The trip and close cannot be programmed to operate as failsafe. Shorting bars in the drawout case ensure that no trip or alarm occurs when the relay is drawn out. However, any output relays that have been programmed as failsafe, including the self-test relay, will de-energize. Any device connected to the failsafe relay terminals will detect this change in state. An LED indicator on the front panel will light when the associated relay is in the operate state. This relay has dedicated trip and close contacts. These contacts will only operate when the relay issues a trip or a close command and cannot be programmed to operate at any other time. The trip contact, R1, is intended to be used as the main trip contact. It should be wired such that the breaker is opened when conditions warrant. The close contact, R2, is designed to energize the close coil of the breaker whenever the relay issues a close command. The close command can be initiated by the auto-reclosure scheme in the relay, any remote close signal, or the voltage and frequency restoration functions of the relay. Supervision of a breaker trip or close coil. The relay is equipped with 2 independent coil monitors, able to supervise the trip and close circuits. All that is required is that the supervision circuits be paralleled with the R1 trip and R2 close relay output contacts as shown. If connected as shown, the supervision input circuits will place an impedance across the trip and close relay contacts that will draw a current of 2 milliamps for an external supply voltage from 30 to 250 volts DC through the breaker trip coil. The supervision circuits respond to a loss of this trickle current as a failure condition. Circuit breakers equipped with standard control circuits have a breaker auxiliary contact permitting the trip coil to be energized only when the breaker is closed. When these contacts are detected to open by the 52A or 52B inputs of the relay, the trip coil supervision circuit is automatically disabled. This logic ensures that the trip circuit is monitored only when the breaker is closed. If trip coil supervision is enabled and the breaker state bypass option is selected, the coil supervision circuitry will monitor the coil circuit for continuity at all times regardless of breaker state. This requires the installation of a resistor as to create an alternate path around the 52A contacts in series with the trip coil when the breaker is open. If that continuity is broken, a coil monitor alarm will indicate a failure in the trip or close coil circuitry. The chart shown gives suggested values for the resistors depending on the control voltage used. The relay is also equipped with a high-speed solid-state trip output. This output is designed for applications where it is required to key a communication channel. It is not intended to operate the trip coil and cannot withstand the current required in the tripping circuitry. Auxiliary relays R3 through R7 are intended to be used for special control functions, such as sending an upstream remote trip command to a breaker on an IOC fault. It is a good idea to decide early on what function each of these relays will perform to avoid assigning conflicting functions to the same output. To ensure conflicts in relay assignment do not occur, some precautions have been taken. All trips default to the R1 trip output relay. All close commands default to the R2 close relay. If the transfer scheme is going to be implemented in the relay, there are a number of logic inputs and relay outputs required for specific functions in the scheme. Please review the transfer scheme for the required inputs and outputs prior to assigning the output contacts of the relay. The failsafe self-test relay R8 will operate, in other words, de-energize, if the relay detects an internal fault or power to the relay has been removed. This output may be monitored with an annunciator, PLC or DCS. Another application is to wire the self-test relay normally closed contact in parallel with the trip relay auxiliary on a breaker. This will provide failsafe operation of the system. The breaker will be tripped offline in the event that the relay loses power or has an internal failure and is unable to provide protection. The relay is equipped with 3 independent communications ports. The front RS-232 port is designed for direct connection to a PC. There are also 2 communications ports located on the rear terminals of the relay. COM1 can be configured as an RS-485 or RS-422 communication port. COM2 is a dedicated RS-485 port. The front RS-232 port requires a straight-through RS-232 cable to connect it to a PC. It is intended for accessing settings, event recorder, and oscillography files, as well as upgrading firmware to the relay. The baud rate and parity are programmable. The rear communication ports are independent RS-485 ports, with COM1 having the ability to be configured for RS-422 hardware. Both ports can be accessed at the same time and are intended to be connected to a Modbus communication network. A maximum of 32 devices can be connected to a single daisy chain. Baud rates and parity can be set independently for each port. To reduce communication errors caused by noise, shielded twisted pair cable is recommended. The cable should be grounded at only one end, either at the relay or the master device. Terminating resistors and capacitors are also recommended to reduce interference.